version 5 about embodied carbon. Thank you, Erica, for starting the recording. And then we have a quick announcement about the Timber HP field trip, and then 3 presentations. So Kristen, I'm going to pass it off to you.
Morning, everyone. Yes, so I'm in the materials tag group for the LEED version 5 materials credits. And as we're looking at the next version of LEED, we're talking a lot about embodied carbon, and just wanted to put the question out to this group, if there were a prerequisite for that, if you take the building life cycle analysis credit, and there's a prerequisite there, make that a prerequisite. What would that look like? Where, not every LEED has to consider, everyone in the country and other countries as well. So it's a low bar, but we're starting to formulate what that might be. Is it just asking people to baseline their projects? Or is it actually doing a LL building LCA? And then what might that look like for existing building, LEED existing building framework, as that's a little different. So if you have ideas or thoughts on what that should look like, you can put them in the chat, or send me an email. I'll put my email in the chat. But it'd be great to hear what people are thinking. And just so you know, the research we're looking at is all of the policies that are coming out across the country, jurisdictions that are asking for embodied carbon information, whether it's related to waste or energy. And in general, when we talk about projects being required to report a baseline, is it a whole carbon number, or is it just operational carbon? Or is it just embodied carbon? So we're trying to push USGBC to think a little broader about what, assigning a carbon number to a building might mean. And if anyone has any, I have like 30 seconds if anyone has a question they want to ask now, but any clarifications? Yeah, Michael, I see that. There are a lot of contractors in the group, and just so you know, the group of materials tag people is materials tag, and I guess committee is a couple of architects, but mostly a couple of developers, manufacturers, and contractors. So and a couple waste hauling companies. So I feel alone in this sometimes, but thanks for any thoughts you might have. Back to you, Nicole. Oh, Jean, do you have a question? All right, great.
Kristen, thank you very much for sharing that. If you want to plop that question in the chat as well, people can kind of mull on it as we continue. I am going to share some information about the upcoming Timber HP field trip. Michelle, Jim, do you want to do an intro on this?
Sure. Jim, do you want to start, and then we can see if Scott or Addie want to add anything? I should say that Jim Burke from CBT has generously offered to organize the field trip from the CLF CBT BE Plus side. So I'll let you take it away.
Yeah, and I think both Scott and Addie are on the call this morning. Scott Johnson from Timber HP, who between Lunch and Learns here and some of the other times we've met and talked, we've been working on getting a trip up there to take a look at this, but this is all kind of coming together with the full group here. So I think the logistics are getting close in the itinerary and the agenda. Scott, I don't know if you want to give a quick rundown of what the day may be.
Yeah, sure. And I'll be very brief because I know you've got a ton on this agenda today. We've confirmed that we're good to go, meaning the company, Timber HP, for October 17th. And we're going to work with you as a chapter, as well as Built Environment Plus, to fill the bus, so to speak. And we're going to try to make it easy. I did confirm with the bus company that we will be able to pick up at the South Station. We'll love to get some input from people in terms of what T-stop in Somerville would be ideal, because they can help us, but we just need a consensus of where most people would be coming and commuting into. So please put that out in the chat, and if somebody can grab it, that'd be great. Get you up to the plant, and Matt O'Malley will kick it off. He's the vice president, but you might know Matt, many of you, from Opal, and we'll have lunch ready to go, and we'll get you out into the factory for a tour, hands-on, fun with some different details of exterior walls and such. This is also a 2 AIA learning unit credit that's been approved by AIA Washington. But yeah, it's a long day. We'll also have food on the way back. We'll pick that up in Portland and get you back to the drop-off spots. But we'll have a clean itinerary PDF document to send out to everybody coming from your association, with a link to sign up, etc. So I'll leave it at that, Jim. Hopefully that covers off everything quickly.
Yeah, I think that's perfect. I know we're looking for a maximum, I think, Scott, of 50. That was the bus capacity, but somewhere kind of in between 30 and 50, I think is what we're looking for.
We purposely went for a big bus so that people could spread out too. There is Wi-Fi on there as well, so you can continue to get your work done.
Yeah, I think that's it. I guess probably to make it easy, so I'll put my email in the chat so everyone has it. And I think the only thing we need to figure out is that kind of north side of Boston pickup, if it is Somerville, if it is a T-stop, if everybody, I don't know where everybody's coming from ultimately. I'm kind of in that area, so that would probably be where I would head for. But let me put my email at least in the chat, and we can at least kind of put together this list. I think one thing we want to make sure is that we don't get a lot of people saying, yes, I'm going to go, and then day of backing out. We want to make sure that we've got a full group that makes the trip.
Thanks for that, Jim. Thanks for the opportunity as well. I appreciate it.
And just one more detail. So Timber HP is sponsoring the entire trip. So it's essentially free for people to attend. But to Jim's point, in order to sort of create a little bit of a commitment on the part of people signing up, we think there's going to be a small donation required to one of the various organizations that are involved, just to sort of like have that, commitment when you sign up. So that will be on the final invite. But it will be a pretty, nominal amount, because Timber HP is generously supporting the whole trip.
Thanks, Michelle. And thanks for your time, everybody.
Thanks, Michelle. And
Thanks,
you,
Scott.
Jim, for offering to organize. Very much appreciated. I see Lynn, Aiden, and Sunny on the call. We have presentations from all of them this morning about measuring embodied carbon on projects. So I'll pass it off to you.
Awesome. Thanks, Nicole. I'm going to start us off with Aiden, just to talk a little bit about, gosh, I feel like the study was done quite a few years ago now, so it doesn't feel as sort of relevant, but maybe it will be for some folks. And it was sort of the kickoff for HMFH's, the firm I work for, process beginning for like implementing carbon workflow. And then we were lucky enough to have Aiden, who will be speaking after me, in our office this summer to sort of work together with myself and a couple of other folks in my office to create sort of the ideal carbon workflow for our office. Anyway, so let me share my screen. And please feel free to interrupt, or if you have questions, I'm happy to answer them. I'm going to go through this case study pretty quickly. So if you have any questions, just put them in the chat, or feel free to speak up. So I worked on this project called Bristol County Agricultural High School, and it was a pretty awesome opportunity because it was a collection of 6 buildings, 2 of which were their sort of main academic buildings. And One of them was existing and it was in excellent shape. And so we were able to sort of keep that. And then the new building was primarily a science center, but still academic classrooms. And they were effectively the same size. And so this study compares these two buildings. So I'm going to go through that now. Should probably figure out how to do the full screen. Give me just one sec. Here, so let's just do this. Okay, we already said that. This is Bristol Aggie. The interesting thing about this is it's really a campus, and so it's split by a pretty major roadway. Sort of top left is the renovation, and top right is the new building. I'll be referring to them as Gilbert Hall, which is the renovation, and CSE, or Center for Science and the Environment, which is the all new build. I do want to make sure that everyone is aware of the people that helped out on this project. We know that we can't do this in a vacuum, and I'll be honest, I actually forgot to put the contractor on here, but they should also be on here. The contractor was Gilbane. And just knowing that this all requires effort and coordination between multiple disciplines and far into construction for this to be effective. So this is the existing campus. It's a 220-acre working farm along the Taunton River. The yellow line indicates the properties that the school owns. The white are all of the buildings that are within the footprint of the campus and outside it. Again, this was the 6-building project, 4 were new construction, 2 renovations, and of the new construction, 3 were timber buildings, 2 mass timber, and 1 was just a stick frame building. I won't be talking about the timber buildings for this particular presentation, but they're also a pretty fantastic story among themselves because they were part of a public bid process. This is the existing site plan, so I'm going to zoom in on a little bit. Actually, I'll go back. Hopefully you can see the blue lines. That's the floodplains. We were pretty limited to where we were going to build, and plus it was a working farm, so a lot of this was sort of slated for agriculture and needed to grow crops for the farm that the school runs. So existing site plan here. This is the new site plan, and we'll be talking about building 3, which is CSE, and building 6, which is Gilbert Hall. A little bit more about the existing building. The main facade, which is shown in the photo, is the existing building, and it's primarily timber, but it has masonry bearing walls, and then there were a couple of additions, and so there were just a myriad of structural elements on this project. I mean, we had waffle slab, we had wood framing, we had steel framing, and there's quite a bit going on. The new addition to this, which created a sort of vertical circulation tower, is exactly the same as the new construction project. Here's a little makeup of the envelope. We did upgrade the thermal properties of the envelope. We worked with an envelope consultant and a masonry expert to figure out the most appropriate intervention for this particular wall. And this is just what it's made of. This is the Center for Science and the Environment. It's a steel frame cast in place perimeter wall and column footing, concrete slab on grade, composite deck, 2nd and 3rd floors, and metal roof deck. The envelope masonry veneer, metal panel and light gauge studs back up. We've got aluminum curtain walls, and then we've got sloped standing seam aluminum roof. And then the flat roofs are all EPDM membrane. And then the vegetative roof is well, there are 2 vegetative roofs on this, and they're all fluid applied. This is the envelope for new construction. So there's brick, metal panel, and stone. We're trying to fit within the vernacular of the agricultural school, and sort of pull in nods of stone from the stone walls that were built to hold in a lot of the the animals way back in the day. So both life cycle assessments, we used Tally. We felt pretty strongly that we don't have enough information to really go for the full scope, although we did analyze the whole building for the full LCA. But this particular presentation is really only going to cover the A1 through A3 stages. And we didn't include demolition site MEP for some obvious reasons that I'll go through. And then the goal of this impact, it was to just understand the impact of building new versus renovating when it comes to just pure materials. And here's a graphic sort of describing the stage of which we were analyzing. And then I'll go most specifically into the global warming potential, although these are the all impact categories for product stages A1 through A3. But we'll go through just the top one there. The reason why we we're primarily looking at scopes A1 through A3 is at the time, the baseline from CLF was for that life cycle scope. And we just didn't feel like we had enough information to go much further than that. And at the time, the benchmark for schools in North America from CLF was 230 to 460 kilograms of carbon per meter squared. That'll be important as we keep going. This is the whole building comparison. So these are all stages here, just to sort of give a little understanding of the different building elements and their impact across all stages in an LCA comparison. And so it's pretty interesting to see the new construction versus renovation, realizing, of course, that most of the impact for the new construction is in the superstructure, where with the renovation, the superstructure was primarily there. There were a few modifications. And so we're really looking at the enclosure and what we're doing as an intervention for the renovation. Here are the sort of basic numbers. And what I found pretty interesting about both of these is that they're both under or below the CLF baseline at the time. And we worked pretty hard on the new construction portion of the project to really find efficiencies in terms of footprint, so that we're not building all sorts of crazy in and outs, and the footing wasn't crazy. Our structural engineer halfway through the project switched, and when we got a new one, it was fantastic and was basically like, we're gonna redesign this and cut out, I don't remember the exact number, but about a quarter of the steel in the project. And so really working with the structural engineer to make sure that we were building the structure efficiently too was incredibly important. And sort of basic numbers with this here, there was a 28% reduction in carbon when we're comparing the new build versus the renovation, which I think is pretty significant. And then here we're looking at the life cycle stages. And this is, again, the whole chart is showing all stages, but the black line along each of the two is showing just A1 through A3. And this graph is really just showing the importance of paying attention to materials in the product stage and why we were specifically looking at that and the impact that they have on the overall life cycle stage comparison. And I'm going to go into some of these materials a little bit more specifically. So concrete, masonry, and metals, those things are pretty high on both of these graphs. Concrete specifically, the makeup of the embodied carbon within the analysis for the Science Center, 30% of that was attributed to concrete, and that's obviously because we built a new structure. And then in the renovation, only 5.1% was attributed to concrete. So it's pretty interesting the impact that we see on the different materials in the new construction versus renovation projects. And then with the metals, it's still pretty high with the new build, but it's significantly higher in the renovation because that was the major intervention. It was building an interior partition that held the insulation for the entire envelope. And so that's about 89% of the embodied carbon contribution to the material stages of this project. And it's important to note that industry standard has a pretty high recycled content for metals. So we really do have to work at sort of reducing that number. Sort of simple terms, do we build new or renovate? For this particular project, it made a lot of sense because it was in excellent condition. And we felt like it was the right approach. This analysis was done after the fact. We did take some steps to try and reduce materiality within the new build and the renovated project, but there wasn't really a question for us on this one. We were building new and we were renovating, so it just created a great opportunity for understanding the difference between the two. And then these are a few of the photos of the renovation. So the far left side of this photo is the existing building, and then the thing that we're looking at straight on with the B is the addition to that existing building. We did add the stone on the bottom, and then sort of turn the corner, and here's that vertical stair tower that starts to connect this building to the rest of the campus. And then this is the new construction project. We worked pretty hard to reduce the interior materials and expose a lot of the systems. It was a teaching center, so we were able to do that and just sort of show the kids how the buildings were working. And then in all of the buildings, we started to provide graphics that explained what was going on. This is a huge graphic about the global carbon cycle. And so we go through the different things that are the different sinks, and we go through the different interventions that are either contributing or assisting in carbon reduction or reduction in the environment. And then the left photo is just showing all of the exposed systems so that you can see that we're sort of cutting out materials as much as possible in the interior. This is our start or attempt at trying to encourage other people to explore strategies at reducing their embodied carbon. So this is the beginning of thinking about what that workflow might look like on projects. And so we sort of talked about different strategies for reducing carbon, and then how we would use these to inform design, both in specifications, through baselines, and then the different kinds of analysis tools that are available. We specifically use Tally. I haven't actually used any of the others except Kaleidoscope. And then here's the rough workflow, and I'm very excited for you to see Aiden's new workflow, because this is these are just very basic things that you can do in the process that we started to look at. And then Aiden.
Yeah, well, I mean, they are basic things, but they're important things. But this summer, I really just dove directly into the world of workflow and life cycle assessment, and how we can rethink as architects how to change our perspective on the ways that we design. So I started off with just thinking, okay, I'm going to create this large booklet resource for the whole office to be able to use. So I wanted to start with life cycle assessment fundamentals. You can keep going, Sunny. And the very first thing is I wanted to define for everyone to see, like, why life cycle assessment? What are we doing? What are the reasons? And this way, like, everyone can just get an idea of why to be conscious about it in the work that we do, whether it's environmental responsibility, trying to find cost savings for our clients, or even just thinking about designing for the future for disassembly, or just all these new ways of designing. Next. And along in this booklet, I put together a few different key concepts. So for example, the environmental impact categories, explaining what they are, why we should be thinking about them, graphically showing some cute little icons to explain, how it's affecting the world we live in. Because, we need to define value in these assessments, and the impact categories is a way to define that value. So it's an important thing to really understand at the start of it. Next slide. And then after all of that background research, I jumped right into what I called the carbon conscious design workflow. Really just a large spread of the different paths and networks that would be used throughout the different stages of the design process. So beginning in pre-design, going through all the different steps to even the building's use, and when the building is eventually demolished or reused or taken down. Along the way, this drawing wasn't finished completely, but it kind of gives the gist of all the different stepping stones and key points in the process where you should stop and reflect and think, how can we be conscious about the materials we're selecting, the subs that we're meeting with, how can we educate them to make as much decrease of impact as possible? How can we iterate and find the little circular elements in our design? And yeah, I'm just going to go through that workflow in some sort of fashion. Pre-design, this is where the most impact can be made for the cheapest. Setting our goals, really communicating and acting as soon as possible can always lead to a dramatic decrease in whether carbon footprint or selection of healthy materials. It doesn't matter. As long as like our mind is in that headspace, these projects can really advance. And then in schematic design, we're starting to, get a form together, understanding the building we're making. So we're learning to optimize and compare as many different strategies as possible, and progressing forward to constantly think, how can we make this even better? Design development, this is where, so HMFH uses Tally. So we're thinking about that Revit template file. How can we have, previous systems that we've performed life cycle assessment on, how can we keep them and reuse them and shorten the process? But also creating that baseline whole building assessment report, just so we can kind of gauge somewhat where we are and whatever impact we're looking into. But we're also reviewing the strategies and the goals that we set with the client, with our structural engineer, whoever, and just still moving forward. Construction documents, now we're starting to really look at materials and pick the materials, refining the model, confirming that the strategies are going to work, and making sure that it's outlined for the beginning of the project actually being built. Construction, what I found, it's mostly about integrity and tracking and making sure that everything that we designed for actually is happening and implemented, whether it's procurement or not. But at the end of construction, performing that whole building life cycle assessment once again, and just make sure that everything we designed for is as accurate as possible. Did we do a good enough job? Where are the pitfalls? How can we be better in the future? And then use, this is sort of the mystery feature of the process, but we're handing off this new building. How can whoever's in that building think about this as well? How can we educate them on the systems that were put in? How can we educate through signage for, say, students, but also following up and making sure that there's even like a plan for replacement, because replacing and maintenance, that's another part of the life cycle assessment. And then also the end of life of the building. Is there a plan in place? Is there any considerations? Yeah. So after doing that research, I looked at all the different tools that are available to HMFH. So I created this little toolbox and the different connections and how it can be used. I investigated a variety of tools that were being used, that weren't being used, that even are in a beta stage of development. And really, I just wanted to find a way to match the actual tools to the workflow that I had put together. There's so many, this isn't even all of them, but I think that these work together well, and I'll just go through each of them really quickly. So at the beginning of the project, like I said, you're planning, you're trying to make these decisions. The two buildings that Sunny just talked about, retrofit versus not new construction, there are resources to investigate that. So the CARE tool, the EPIC tool, a quick way to
one-on-one with Heather. I know you need every minute.
quick way to look into if the decisions you're making are the right ones. So these were good tools to use. Then looking at like the concept formation and confirming not only the carbon impact, but also just the environmental, and say for, Climate Studio, you're looking at the daylight availability, but then there's new tools like Autodesk Forma, which show ways to automate that process and use generative design and quickly make massings that you can then perform life cycle assessments and compare the different strategies. So this is a good way to use that at the start of the project. Kaleidoscope, HMFH has used before. I've used it before in school. Just, it's a great tool to look at, like, say you're looking at two different wall systems and just get a general idea of, okay, this detail has way more eutrophication potential than this other detail. And then you can show that graphically to your client, to whoever engineer you're working with. It's just a good comparison tool. And then the real meat of what is happening, Autodesk Revit, but then using Tally like HMFH has done in the past. But then there are new plugins and new tools with EC3 and their new plugin, TallyCat. It's a direct connection to Revit, where you can build your model in EC3 and then directly link it back to Revit, and you can move back and forth, create assemblies, and find the exact materials that you want to use. And then another big part of the research that I did was data representation. So I took some old Tally reports that they had performed and I put them into Power BI, and I created a template just to find the best way to represent this large amount of data that's coming out of the Tally report. So like Sunny was saying, this was for Gilbert Hall, I believe, this picture, and I wanted to show the different environmental impact categories and where the most of their impact is happening. So each one of these lines is showing those 6 different categories, and as you can see in the A through 3 product phase, that's where the largest percentage of the impact is happening. And I think that's it. Yeah, really, it was just looking at the big picture and trying to find all the different connections, and I think it's a good start.
Anyone have questions on our little bit before we pass it off to Lynn? Awesome, we'll keep going.
Go ahead, Lynn, sorry.
Yeah, sorry. I will share my screen, and Nicole, feel free to jump in and comment on any part. I really don't have the most comprehensive grasp on all of these projects like you do. So so I will share my screen. Hopefully you're all seeing what I'm seeing right now, which are my slides. Okay, great. So, hi everyone, my name is Lin Mai, and I was the summer intern at Isgenuity. And during my time there, Isgenuity was still really at like the start of understanding all the carbon analysis tools and the process of getting there, and then really start like working and using these tools to analyze a couple of projects. And so we are very in the infancy stage of understanding these tools and how we can use it, and hopefully understand it enough to establish a framework later on for the whole firm. But I will dive in. A lot of these information overlaps with Aiden and Suni information, but bear with me. Okay. So most of us generalty projects are hospital and healthcare projects. So I think first it's important to understand like the carbon benchmark for hospitals. So World Economic Forums determines that healthcare accounts for 4% of global carbon dioxide emissions, and it emits 2.5 times more greenhouse gases than commercial buildings in the B1 to B3 stage, which is like the use stage. And in GBA report, hospital average carbon footprint has remained fairly steady at 244 to 292 kilogram of carbon equivalent per square meters per year. That translates to 50 to 60 pounds of carbon equivalent per square footage per year. And according to an RUP study, that range is around 150 to 350 kilogram of carbon equivalents per square meters. And so the numbers are quite consistent throughout. And I just want to like show this beautiful graph that Grumman Brutus associated just to see where all of the healthcare projects that they examined lie in based on the carbon footprints that they produced. And yeah, it's like a wide range, but it's mainly the average is around 50 to 60. And it's also important to see that, you know, for the on-site electricity generated healthcare projects, these they have like below average numbers. So on-site electricity generation do matter, and also heat pump and geothermal system, which brings it down to like 30 and 20 pounds of carbon equivalent per square footage per year. But yeah, so I spent a big chunk of my time at Strategy looking at schematic design carbon tools. So you know, Care, Beam, Zero Guide, Epic, and Kaleidoscope. I love the tools that we already talk about. So it's great to use this during the schematic design stage, and then is to understand like, you know, what are the low carbon materials and making product decision in the early design phase. And then some of these tools also provide client ready results, which is great. So you can bring these in during client briefings or presentations and show, you know, how much an impact like a material change or like a decision can make. So talking briefly about Kaleidoscope, you know, this is an apple-to-apple tool looking at all environmental impacts or just the product stage. It's fairly easy to use, 15 minutes. And I was a beginner when I was using this, so it was like very beginner friendly as well. And my favorite part about this tool is that you can like make your own wall assembly or floor assembly and start to see like how much carbon impact each assembly has. So they have like a little calculation tool when you scroll down, but and then we also look at Epic, which is a pretty terrific tool. You know, we create scenarios to decarbonize the projects, and then we can compare the scenarios, assess embodied carbon and operational carbon of the project over 30 years lifespan. Still pretty easy to use, which is great news. And also client ready results with beautiful graphs and pie charts. It takes around 15-30 minutes to use it, and then you do have to input a couple of data like what's the footage of your building, or like whether it's steel frame or concrete, or whether it's you know, on-site electricity or mixed use kind of like energy. But yeah, pretty easy. Beam, which is I think the most accurate give the most accurate results. It takes longer to use, and is for us it took around 4 to 6 hours. We have to look at construction documents, we have to look at Revit, but really is allow you to like be very specific of like what materials you use for each categories, and then it let you see, you know, for instance here you can see the footing slab is like 363,000 of kilogram of carbon equivalent. So you can see like the breakdown of these categories and which one like make up the most. So for this project that we did, which is I think the Franciscan hospital project, it was the windows that you know has the most carbon impact. And then you after seeing this, we can like ask questions of like, okay, so how can we bring that number down? Like what are the decisions we can make? Either like maybe double glazing would be better than triple glazing. So yeah, and it's very hard to use for the first time, but it gets better as you use it. And then the care tool, which allows you to like compare do nothing new building retrofit. But we already covered that, and it also let you set targets, which is awesome. Zero Guide tool, this helped to let you estimate embodied operational and transportation carbon. And then you can like assess whether your project achieve IOFI net zero, a certain LEED rating. But I find that not that reliable, so don't rely on it too much, but it can give you like a rough idea. And probably easy to use. It takes around 30 to 60 minutes, and I think that graphically this is the most beautiful tools. And then they also let you know that whether your like carbon impact of your building is within like a better, good, a baseline range, which is awesome. But it's not that accurate because we don't get to input that much data into it. So it's really just a rough estimate kind of tool. And then for a company, I did this chart to compare all the tools. So we know what to grab for what stage of the project, and then what purpose that we're doing. So if we want to do a material comparison, maybe it's a good idea to use either beam, kaleidoscope, or like understanding energy, then Epic and Caretool would be great. And then for the schematic design, we do like their I use Franciscan Children's Hospital in Brighton, Massachusetts as the base project. So this is the project is like a new project. It's around 100,000 square foot clinical building. It has a new gym with a relocated entrance, and then it will be located in the parking space building 7, which was constructed in 1949, and it will create a clinical space in which to care for patients with complex behavioral health and medical conditions, and a new public space for FC. And it will also include both pediatric post-acute care, psychiatric inpatient care on multiple floors, as well as entrance lobby with varied gathering spaces and key family resources areas for the campus, among other services to be defined. The construction of clinical building will allow for the needed expansion of these services to meet the growing need of the children with behavioral and health medical conditions. And so these are the results that we produced for the Franciscan Children's Hospital project. And really it's just we kind of like have an understanding of how to use this tool with the project, and you know, a couple of numbers that we produced. So for beam, we found out like for the product stage is around like 2,300,000 of carbon equivalent, which is pretty significant. But when you put it into perspective, you're looking at Epic, and then you see like, oh, for the product stage is like No, for like 30 years lifespan, it's like 135,000 tons of carbon equivalent. Yeah, it's free just for us to get a rough understanding of how to use these tools and see if the results are consistent throughout all of these tools. And they are pretty consistent since a lot of them share the same data source. And then for the develop and design construction document carbon tools, we use Tally, and then we did our first Tally analysis with our Broxton project. So our Broxton project is the redevelopment of a former nursing home. So this is like an adaptive reuse project for Boston Medical Center, which allows for the development of 56 lock-in patients behavioral and 26 clinical stabilization service bed, direct access to outdoor courtyard, including walking path, shelter areas, gardens, events, exercise spaces, which create ample opportunities for healthy interaction and physical activities. The hospital location and the demographically diverse city of Brockton represent a meaningful step in addressing mental health treatment disparities among a variety of populations. And then it's also like, in addition to representing a significant increase in availability of these much needed psychiatric resources, this project was designed to minimize its environmental impacts. The combination of adaptive reuse and net zero build results in a sustainability driven facility. This project makes use of the existing building structure, which significantly save on new steel and concrete, while reducing the impact on landfills. So the entire envelope was upgraded with a new facade and skin designed to exceed energy code and create a tight enclosure following a passive building standard. There's also installation of PV panels on roof and parking lot canopy with 80 geothermal wells to contribute to the goal of like achieving net zero on site. And so here are like a couple of the results that we produced on Tally. And so for the product stage, the global warming impact is around 850,000. And then for per area, that would put it in around 150 of kilogram of carbon dioxide equivalent per square meters, which is way below the original benchmark that we talk about, which is around like 250. So retrofit projects are really more sustainable and have less carbon impacts on the environment. And then we also look in deeper to see, so this is pretty consistent to most projects. There's always product stage that has the most carbon impact, followed by the use stage, maintenance and replacement, and then end of life stage. And then for these, we also got to have a glimpse of like which category is most carbon intensive. So for us, it's the lightweight and the structural concrete, which takes up like 30%, and then followed by wallboard gypsum, which are like 12%, and then there's I think the steel category. And then looking at this as like a building overall, it's like 53% of the carbon impact comes from the flooring system, followed by the wall system, which are pretty consistent too. And that's about it. And Nicole, if you want to add anything else, yeah, that's just all I have for my presentation.
Are there any questions from anyone about any of this? That was a lot of information in 50 minutes. I will just say about the Brockton project, it was a nursing facility originally built in the 1970s. And so the structure was concrete walls on the exterior and on the interior. And the project team worked really hard to maintain all of those structural CMU walls. And they tried diligently to convince the client to use a rain screen system outboard of the CMU to achieve the high performing envelope, but ended up with EFIS. And so everyone was kind of apoplectic about all the foam on the building and how it had like completely destroyed the embodied carbon performance. And then we did the tally kind of postmortem and realized that the amount of embodied carbon just in the tiny bit of foundations that were poured and the extra concrete that was used to modernize the building, along with the metals, completely outweighed everything that we did on the envelope. So lesson learned on that one. That was really quick and efficient. Kristen, do you want to kind of repeat your question and see if that spurs any conversation while we have everybody together? There's still about 30 people on the call. I think people were still joining when you went over it earlier.
Yeah, sure. I waited a little bit to put it in the chat, but essentially we're looking at lead version 5 and how we can kind of raise the bar a little bit on what prerequisites might look like for projects. So for existing building, existing building rating system, they're talking about making a prerequisite that the building owners would have to, or the project team would have to set a baseline and targets for operational carbon. And we'd like to see kind of a more holistic picture of carbon for projects. So what would that language look like, or what's a reasonable request to require projects just to be a lead project? And then if you take that to the new building or the new project rating systems, you know, what would a baseline look like? Would they, for example, you know, put it in EC3? Is that a requirement? Just to get a project just started in EC3, something like that. So any thoughts you might have on minimum thresholds, email me. I'll put my email in the chat again, or else we can certainly talk about it here. And for that matter, if you have any other thoughts on lead materials credits, they're all up for being revamped for version 5, which is coming out soon. So share your thoughts now or forever hold your peace.
Kristen, as it relates to the baselines, I feel like that's something that I've heard and I've seen a lot of people struggle with, like figuring out, how do you set an embodied carbon baseline? Where does it come from? How do you understand whether or not it's appropriate? The current lead credit sort of allows you to pick your own baseline based on sort of what you would do. We've had some pushback on projects where we've picked our baseline and they've come back and said, well, this isn't sort of typical to the Northeast region or industry. And so we're sort of like, wait a minute, I thought you said we could pick our baseline. Because like for this Bristol project specifically, there were no SCMs, supplemental cementitious materials used in the concrete. So all of those numbers were based on like no additional effort to reduce the carbon in our concrete mix, which wasn't necessarily a decision that we made, but the contractor made, and it was something. So like that was a really interesting conversation that we had within our office that then contributed to the conversations on other projects and what their baselines were and how that was going to work. And I mean, now we use the work that this group has been doing. And so I think if there is more concrete guidance on creating baselines, that's incredibly important. I don't know what that guidance would be, but I think I would encourage that in any sort of credit structure.
Thank you. Excellent.
I think the credit, just thinking about the goals of the credit in general is important for thinking about how you actually incentivize it or, create that credit. So is the goal to encourage a behavioral change on the part of designers to start integrating this work into their workflow? You're going to set the credit up differently. Then it might just be putting that credit or putting the project into EC3 or just doing a whole building lifecycle analysis. If you're aiming for data gathering for a future LEED version 6, that's going to set the credit up differently. If you're looking for actual embodied carbon reduction, I don't know that we have a baseline that would be able to set that credit up correctly right now. But I think understanding the goal of that credit is, I think, helps answer the question.
Thank you.
All right, if there's no other thoughts, I'm going to close the meeting. Give us 4 minutes to transition to our 10 a.m.s. Great to see all of you this morning. Thanks for coming, and we'll see you next month. We just remind everybody, we're trying a new thing this fall. We're going to keep the presentations on Friday mornings at 9 a.m. and then every other month for the roundtables, those are going to be on Thursday mornings. And hopefully we'll be able to get a good cross section of people between those two times. Thanks. Have a great weekend. See you soon.